pre-calculus students, this is Mrs. Marshall today, and I'm going to be covering the P4 section. This section, as you can see from your yellow note packet, refers to lines in the plane, and we're going to basically focus on two main tasks. The first task is for you to become an expert and remind yourself of all of the things dealing with slope, and the second half of this note packet and information is about equations of lines and writing good equations of lines. So I'm going to run through a little bit of this first section quickly because I think that we have done so much work with slope in the past and have had several different interactions with the concept of slope. As a quick review, we started off with the basic question about what is slope, and I would say that the majority of the time students kind of refer to slope as the steepness of a line. Or a lot of times students come up with that idea of the rise over run concept, or maybe that change of y over change of x, and use the delta symbol. These are all sort of different ways that we have plainly talked about slope, but we also have a formal definition of how we find slope. And our expectation for you guys is that you should be able to find slope coming off of 2 points by using that great formula that we have seen so often, y2 minus y1 over x2 minus x1. So we definitely expect that you should be able to find slope using that. We also, just to make sure that we're clear, we do have an expectation that you can find slope off of a graph. And when we do have that expectation, he's certainly locating a couple of key points on the graph that you could determine a slope, and then go ahead and use just a counting rise over run in order for us to determine that case as well. So both of those are going to be fair game as far as knowledge and the ability to find slopes off of graphs and from 2 points. I'm going to toss off just a little bit of an example here just in case you need to have that 2-point version once again. So my example here is find the slope between points 3, -1 and 4, 5. Since I'm asking between a couple of points, I'm going to use my formula over here. Just go straight forward. The second y, which is the 5, minus the first y, -1. And then on the bottom, second x minus first x. So on the top, I have 5 minus -1, which is 5 plus 1, or 6. And on the bottom, 4 minus 3. So there's that first slope. We're going to do that a couple more times in some other problems, so hopefully one example is enough to cover there in your note packet. Okay, on the next page, we also have a couple of just those special types of different kinds of slopes, how we recognize those. We kind of put slopes in 4 different categories. So we have just a little bit of some sketching here. Slope should fall into a positive type of slope. Just a reminder that that means when you are reading a graph from left to right, that that graph should be going up with a positive slope. Negative slope in the same way, reading left to right takes us downward. Then we also have a zero slope, and zero slope is that concept of a horizontal line. The difference there with our fourth and final is we have an undefined slope in the last category, and these last two can sometimes get a little bit backwards for students. So undefined slope, remember, just means one that is vertical. In addition to drawing those out, we're going to get to those equations of lines, but I'm just going to make a quick comment now and sort of identify those equations of lines because they're pretty popular also for students with those last two pieces. So I'm just going to draw a little bit of a line right now. Okay, and just remember that when you have a zero slope line, okay, that you typically have an equation that is y equals just a number. When you have a vertical line or an undefined slope, you have an equation that is x equals some number. And those two, we want to make sure that we get straight kind of as some special cases. So have those two down and be quite thorough as we go through some items here in our future, that you can tell the difference between those kinds. Positive, negative slopes, we'll get to those a little bit more with your equation. Zero and undefined slopes, we're going to remind ourselves those equations are a y equals and an x equals respectively. All right, the other kinds of special things that we have learned about slope that we're going to be using right below that is refreshing our memory with parallel and perpendicular lines and their slopes. This should come from geometry. You may have had a little bit of review in Algebra 2 with this as well. But a reminder that parallel lines have and use the same slope, and perpendicular lines use a negative and reciprocal. Slopes. Now, I don't always like to use that word negative. Sometimes students can just say negative reciprocal. I tend to like to use the idea of opposite and reciprocal, so either of those will be fair game, but you want to make sure that when you're looking at two lines that their slopes are opposite sides and reciprocal. And as we also reminder, that reciprocal concept means that you either have an a over b fraction that switches out to a b over a representation, so maybe a slope of 2, for example, then the reciprocal of that is 1/2. So flipping over that fraction, that's that concept of reciprocal. All right, perfect. So that's kind of been our quick review of the slope concepts. It was really, really fast through there. We as pre-calc teachers feel that you have seen that several times in your last few years of mathematics. So hopefully that was just a quick review. If you need more examples or more from your pre-calc teacher, please do ask. The second half of our lesson today, we're going to look at equations of lines. So we'll be doing a little bit more algebraic work here in this last half of the note-taking, reviewing those equations. There are several different kinds of equations for lines that we use in mathematics, but this particular course, we're going to be focusing on 3 specific ones. There is a 4th one that I'm going to mention that we as pre-calc teachers don't always use that language of. It is in the textbook, so when I get there, that will be explained also. But we're going to stick with just the 3 main ones that we know. There are lots of great benefits and downfalls to using each one of these, so I'll try to also touch base on that as I go through the 3 specific ones. So the first type of equation that is most familiar with students when dealing with lines and linear functions is the slope-intercept form. Y equals mx plus b. And the slope-intercept form, quick reminders of those, that m is your slope and the b is your y-intercept. And the slope-intercept form is probably the most popular form to write equations in. It's in a nice y equals format. It's very linear with seeing and identifying the slope. The y-intercept is present, so there's great usage there. It's not all that often that we actually end up knowing a slope and a y-intercept when we start a problem. So one of the downfalls of this is it's not always the best one to use when you don't have slope and y-intercept. A lot of time we are given a slope and a point, and this isn't really the one that we favor students using with that information. So it's really best used when you have the y-intercept info. The second one, which is the one that we do like to have students use, is the point slope form. The point slope form is a form that we typically use often because that's usually what we start with for our information in a context. We know a slope and a point, or maybe we know 2 points and we can find the slope from that using our slope formula from before and using this particular formula. So when I teach pre-calc, I usually have students kind of star that one. This is usually the form that we would like you to start your work on when your job is to write your own equation of a line. and, oops, sorry, let me put the slope, apologies, sorry, point slope form. Forgot to write the title on that, so let me get that on there. Point slope form. Okay, and when we are doing that, what you'll want to do, okay, is usually you stick the point information in the actual subscript ones, and then your slope is going to go here in that same spot where it was. Now we're going to also, before I talk about the third and final form, two of the pre-calc teachers are AP calculus teachers also. So we like to do a little quick shout out that for those of you moving on to AP calculus, if that is you, we tend to use the point slope form a lot, but we also tend to use a y equals format. So I'm going to just jot down that we will in AP calculus find that a lot of times we will move that y sub 1 over and tack it onto the end, okay, of a point slope form. That way we also have this y equals format just like up in the slope intercept. We also can kind of almost see a similar type of notation to the slope intercept and point slope form where it's y equals m. So we don't really need you to be using that form in the secondary piece. We will definitely want you to demonstrate what your textbook will show you is the first part of that point slope form. But just in case you want to start to practice some of that work and moving that y term over to the other side, we're going to put that secondary piece on there. Okay, and then the third and final form that we would like all students in pre-calc to make sure that they are comfortable with is what is more commonly called the standard form. You know what? Sorry, let me be consistent. Apologies. Let me write the standard form down first, and then I will label that. In a standard form, there are some great benefits to it as finding some intercepts really quickly. There's the ability to graph sometimes this form very fast with using intercepts. But there is a big pitfall here and a big kind of downfall on using the standard form is it's very rarely something that you can actually plug information in. There isn't necessarily a direct value for A, B, and C that correlates with slopes and intercepts. There is a roundabout way of doing that, but not one that's very convenient to actually put. So if you need to write things in standard form, you want to start still with that point slope form or maybe even the slope intercept form if you have a slope and intercept, and you need to get there to that standard form by using some algebraic means. So not a form that we're going to directly ever plug in. And we're going to do an example of that so I can show you that piece. But as far as the information and what we're going to be given and using that, it's not one that's directly there. The last little part before we go over those few examples of our work here is we're going to make a note on this particular set that our textbook uses what is called a general form. And it's in the textbook, in the lesson, it's in some of the questions that you have for your homework and the odds. And the general form is really the same thing as the standard form, except the C is moved over. So it looks sort of like this in a generic format. So the general form wants you to get 0 on one side and everything onto the other side. Now we sort of all agree as pre-calculus teachers that this particular form is not very popular anywhere else outside of our textbook. It is not a part of an ACT question to our knowledge. I have never seen it be on a calculus question or on anything else besides really this section of our pre-calculus book. So we are fine if you are going to write things in a general form to answer the questions in the book, but we're going to be honest, we would really actually prefer that you would use the standard form anytime that you see the concept of general form. Knowing, of course, that the back of the book will be slightly different, those types of things. But really, we kind of like to draw a line in the sand here as far as the forms that we prefer and stick above the line with using slope-intercept, point slope, or standard form. But this general form does exist where we put everything on one side, set it equals 0. So the choice will be yours. We as pre-calculus teachers will accept general form if that is what is asked of you in the homework. But we would actually rather see you writing more of standard form because that's really what we're going to see most of the time outside of this textbook section. So hopefully that part is clear. So the last part of my talk today is really just taking those forms and actually physically writing our own equations out. And so when we have to do that, your job is to take the information that's obviously given to you and put it in the form requested. The form that is being asked of you is really important because that's the form that we want to see your final answer. Like this first example, we are looking for you to find a slope-intercept form equation. So with the slope-intercept form equation as our final, then I better see a y equals mx plus b form as my final piece. Sometimes I'm given direct information to plug in. Sometimes I have something missing that I've got to find. So the slope-intercept form here in this problem, I'm given a couple of points. Now, in order for me to directly plug into slope-intercept, I would have to know the slope, and I would have to know the y-intercept. I don't have either of those pieces here, so although my request is slope-intercept, I think I'm going to probably use a different form. I know that I can find the slope between 2 points, because I already had that quick lesson. So I'm going to do that, and I'm going to go y2 minus y1 over x2 minus x1. So this problem, I have a -1 divided by a -7, or a slope of 1/7. So I have a slope, so I've got that piece. I still don't have a y-intercept, but I do have points. And this is what I was referring to earlier, where you usually have this type of information. So we're going to start this problem with point slope form and then just change it into slope-intercept form. So I'm going to use the slope that I just found, and I'm going to pick one of the 2 points. Doesn't matter which point you want to pick. I think I'm just going to pick this first point of 4,2 because it's nice and positive, and I'm going to use the point slope form. So I'm going to write that point slope form down here, and then I'm going to plug stuff in that I know. I'm going to keep the y a y, and the y sub 1 is a 2. My slope that I found was 1/7, and my x sub 1 is the 4. So I plug those pieces in. And then at this point, I have the point slope form, but I want slope-intercept. So I'm just going to use my algebraic skills and get the y equals mx plus b format. So I'm going to go y minus 2 and keep that there. I'm going to use a distributive property, and I'm just going to keep my fraction 1/7. If you want to change that into a decimal format, you can. I'm just going to leave that part there. And then 1/7 times 4 will be a -4/7. And then my last little part, in order to get y equals mx plus b, I'll just add that 2 to the other side. And I get y equals a 1/7x. And then here, again, I like to sometimes pause and reflect on the fact that we are taking some fractional work and adding it to a nice whole number or integer piece here. And since I've been working with fractions, I'm going to stick with fractions and kind of practice not using my calculator, working with some different kinds of numbers. So I'm reminded just briefly that 2 is the same as 14/7. And so if I take 14/7 minus 4/7, I'm going to get 10/7. And I'm going to leave my answer in fraction format, but you are absolutely capable of changing that to decimals if you would like to. So this has gotten me to a nice slope-intercept form, which was my request. And I am done with this problem at this point. All right, couple problems left. So we're going to move on to the next slide here, and we're going to have a request for a standard form equation. And again, I have 2 points that I'm given. So a reminder that I don't have the ability to plug directly into standard form. So I'm going to just do a little bit, once again, kind of repeating from the last problem. And I'm going to start off with needing a slope. So I'm going to do that part, y2 minus y1. And then on the bottom, x2 minus x1. And I can tell already that this problem is going to be a lot nicer. I don't have any fractions to work with. I have a 7 over 7, or a nice, easy, positive 1 slope. And once again, I have a slope, and I've got some points. So I'm going to start off with the point-slope form. Okay, this time, I'm going to just, again, rewrite quickly that formula. The more times we can see it, the more we might be able to get that to memory. I think this time I'm going to pick the 4, -1 point to stick in. Doesn't really matter which one you have. You're going to end up with the same answer as everyone else. Y minus a -1. I'll turn that into a plus. Slope was 1. I'm going to actually put that 1 there, even though it's not necessary to write it. And then I've got x minus 4. And now that I'm in that form, to get things into standard form, I want everything as far as x's and y's to be together, and then the numbers on the other side. But I am just going to take some time here to clean this up just a little bit. Normally I would distribute that slope into the values parentheses, but with a slope of 1, that can slowly disappear. And I'm going to do 2 different moves here and move the numbers to the other side, and then also move the x over with the y. Now, you may have a pre-calculus teacher that would prefer that you do each step individually, and if that's the case, you can do that. Maybe check with your pre-calculus teacher to see if that's important. Otherwise, we now have the standard form of -x plus y equals -5. I also want to point out here that when we get to the spot, okay, some pre-calculus teachers are going to be totally fine with this piece. There is kind of a general rule that when you write things in a standard form, the first term should not be negative. And so it's very common for that particular simplification to occur where we change signs if that first term is negative. I personally, Mrs. Marshall, I don't feel like I have to have students do that, but I do want us to be aware of that part. So once again, you may want to check with your pre-calculus teacher and see if it's necessary for you to switch that sign. There's also kind of a general rule about standard form that not only is the first term not negative, but we also like to have things as integers. So when we want that whole idea, because we don't want it negative, and we don't necessarily want to have a decimal pieces there, you also may need to adjust by having an integer piece. That will really be kind of teacher to teacher in this regard. I think most of the 4 of us pre-calculus teachers here at the high school don't care if you just go ahead and leave that first version with a negative in the front. Just be aware that you can, in fact, switch those things out. If we needed a general form, so I'm going to jump over here and just say a general form, you would just need to move the 5 over and hang up with the x and y. So a general form, if you are checking things in the back of the book, might look something like this, or it might have positive, negative, negative, and switching out the signs depending. Be comfortable with adjusting that standard and general form to whatever works for your teacher or whatever works to match the back of the book, but keep in mind that we would prefer that standard form. All right, and then we have just kind of one last particular request here in your note packet, and that last request is for us to also find some ways to practice that parallel perpendicular concept. So here we have a question of writing the equation of a line passing through a point 6, 1, and we want perpendicular to a line. So when we do that, first of all, 2 things. The type of form of the equation is not basically clear in the directions. It just says find an equation of a line passing through. Say that the majority of us would prefer a slope-intercept form on that part of the question. However, technically any equation for a line will work here. We want this to be perpendicular to this line, so the only purpose for this equation to be given is for us to identify the slope so that we can in fact either use the same slope or use the opposite and reciprocal slope. This y-intercept is not needed for any part of this question. So we want to ignore that part completely. Since we're looking for an equation that is perpendicular, then for our problem, we want to use the opposite reciprocal slope. If this question were one of parallel, we would want to use the same slope. But we're going to use that slope with this point 6,1 that's given to us and go ahead and write the equation of the line. I'm going to use my point slope form one last time here because we do have a point and we do have a slope. So you can kind of see where almost every problem that we give you guys, starting with point slope form, is the best. You'll begin to really get good at writing it down. If you haven't memorized it already, you will by the time you're done with this section because you're going to do it often. Now, technically speaking, I could stop here, and I have, in fact, found an equation of a line passing through the point. Most of the back of the book won't leave that here. I'm sorry, I'm not sure why I had two equal signs. I don't have anyone here to notice that. My fault. Sorry about that. And so I am going to extend this and just get it into a slope-intercept form, just because that will be most commonly used in the textbook. Negative times a negative there, got me a +3, and I'm going to add the 1. So my final answer here is that -1/2x + 4. That's going to be far more common as you check things in the back to make sure you're doing things well. Well, this is sort of the end of our lesson. Our main goals, remember, as we went through this talk, was for us to understand slopes, use slopes and find slopes in a variety of different ways, especially those special cases of slopes that are undefined and slopes that are 0, parallel slopes and perpendicular slopes. And then the second half of our lesson today was to visit writing your own equations of lines, slope-intercept, point slope form, standard form, and then a special side note about that word general form if you choose to use it. All right, have a great afternoon, everyone, and thank you.